Hi everyone. Would wait for an extra minute or two so that others could join in before we start. Um, I, I guess we'll have to start and then, you know, as we go on, you know, others would join in. So, hi everyone. Welcome back to another session of the Developer Experience Working Group session. Um, Last week, I know my colleague um, discussed a technical walkthrough, on how to build like a very good production-ready smart contract system. And for those of you that missed that meeting or that session, this session is for you, right? Usually, the way the DevX working group sessions is divided is usually divided into two. So one is for folks that can meet up with the morning session, that's folks in the APAC region, and the other is for folks in maybe within Europe or within Africa. So in case you missed the last session, this is another session for you. So yeah, we'll be doing like a technical walkthrough, just like in the last session, showing you how to build production grade smart contract systems, giving you an example of how it's been done, and also like showing you the best practices on how to go about them. Okay. So let me share my screen. So 1 second. I'm trying to share screen. Okay. Cool. So, like I mentioned previously, um, the uh, the idea for this session is for me to, kind of like show you how to build um, a smart contract or how a production grade smart contract is being built, right? Going to like introduce you to like best practices on how you can go about them. Things around like docs, how you can write your docs, how you can write your test cases, and how you can even like deploy. So a case in point or a use case that I would want to highlight is this payment subscription system by Anastasia Labs. So this is an example, a very good example that I would want to use for this session. Okay. So basically, what is this repo all about? You know, by just at your first glance, you can tell that this is a payment subscription service, and it is, from the description here, you can see that it is developed in Icon, right? If you remember in our past sessions, we mentioned Icon as one of the languages that you can use to build smart contracts. So as you can see from this repo, this is a smart contract service, right? So the idea of this payment subscription is to facilitate automated recurring payments between subscribers and merchants on the Cardano blockchain, right? So basically, the fact that you can, I mean, from the description, you can tell that this system, is going to run on a multi validator system, right? Because as you can see, it has an automated recurring payment between a subscriber and a merchant. This smart contract also enables users to set up, manage, and cancel subscriptions directly from their wallet. So yeah, so this is like, from what you can see, it's like a multi-validator system. But yeah, I'll still dive into the details so you can have like a comprehensive like overview of like the contract's architecture, the design decisions, and the implementation details. Okay. So from here, from the docs, as you can see, you have like 3 different contract functionality, right? You have the service contract, you have the account contract, you have the payment contract, right? So the service contract is a multi-validator responsible for creating an initial service, right? So basically, in a nutshell, it's just the service or the contract that kind of like allows users to create an initial service, right? That means the assets and is sent to the user, right? So this is like the first service that the user interacts with, right? So that is for the service contract. Then the account contract, because from the word counts, you can tell that it's basically responsible for creating an account for the user, right? And then the payment contract. So the payment contract is like the core validator, right? This is like the main contract that handles the whole, subscription, the whole renewing of subscription or subscribing and subscribing, withdrawing and all of that. So it's more like the core. It's more like the core of the system, right? So these are like 3 different core functionalities that we have in this payment subscription service. Now, before I dive deep into like setting up and all of that, I want you to take a look at how this repo is structured. I want you to have a complete look, right? Because all of this shows you how smart contracts how smart contracts repository should be designed, right? So the design doesn't just end in the code. It also ends in it also covers your documentation. It also covers your tests, how much tests you write or how much test coverage you have, and also how you arrange your repository. It is very important. So from here, you can see that first, they have a docs folder, right, which is super essential. So the docs folder contains all the documentation for your project, right? And then you have the lib folder. So the lib folder is like where you have, packages and libraries. Rather, in a nutshell, it's basically where you have like your core code, right? Your core code that does, the main, functionality in your app. In this case, this is like the payment subscription, right? So here you can see that it has like all the validators present. It has the account multi-validator, it has the payment multi-validator, it has the service multi-validator. It also contains the tests as well. And as you can see, there is tests for each of these validators. So it's super essential that you understand that the best practice for building a smart contract should include a very good documentation. It should include very good test cases. So you should be able to test whatever code or whatever smart contracts that you have. I should be able to write documentation on how to implement those smart contracts, what it does, and how to implement them. Right? Okay. So yeah. Then there is the validators folder, which kind of like contains, the other validators as well. And then you have like the test readme, and then you have like the readme, and then you have like your icon log and all of that. But the three main things that I wanted to highlight is the docs. As you can see, the docs is highlighted. It is here present in the repo. You have the payment subscription. That's the lib folder containing the core of your application, right? And then you have your validators folder. So these are like the three main folders that needs to show or that needs to be present in your repository. So let's dive deep into how to get started with this repo, right? So like I said, the idea is to show you the best practice on how to build a production-ready smart contract. So to get started, of course, you have to like have icon installed. So like I said, icon is like the official language that you can use to, to kind of like write smart contracts in Cardano, right? So and then for you to build, you have to like clone this repo and then run icon build. So icon has different commands that you can, that you need in order to like run the Cardano smart contract, right? So you can check out the icon documentation to learn more about these different these different commands, right? In this case, once you're done cloning and once you're done, setting up the payment subscription project on your computer, that you run icon build, right? Now, like I said, the good thing about what makes this project, or rather, what makes this project, in my opinion, an ideal smart contract project is the fact that for each validator, for each smart contract that you have here, you have tests to do what? To make sure that it doesn't break in production. All right. So tests allows us to test our functionalities and our code to make sure that it doesn't break in production. So in this case, you can see that there are test cases for different validators, right? And for each of the contracts. So there is a test case for the service multi-level multi-validator. As you can see from each of the service, there is test cases for each of the services in the service multi-validator. There is a test for the success multi-validator, success create service. There is a test for success delete service. There is a test for success update service. Same thing happens for the account multi-validator, and then you can see it here in the payment multi-validator as well. So yeah, this is like the different like screenshots that kind of like shows you how the tests are being run, right? So from a general overview, you can see that in this case, first the the code that this the smart contract, you know, works, and the only way you can test that it works is by writing tests. And then the the and then they went further to write a documentation on how to run these things and what each one does, right? So for example, you can see here they have like this subscription spec. So this is like a spec document on what each of the service each of the smart contract service does. In this case, this is like the subscription. This design spec is for the for all of the smart contracts in this project, right? So you can see here there is an overview, there's an architecture, specification, transactions, and all of that. So let's just dive deep into how the architecture was designed in the first place, what was considered and what was not. And then we'll go down to the specifications, and then we'll go down to the transactions, you know. So the first thing is the architecture, right? So if you want to design a payment subscription, a payment subscription smart contract on Cardano, what do you consider? What are the different things you can consider? So as you can see, let me just zoom this a bit. So as you can see, this is a multi-validator system, right? So which means it has different validators for different services. So in this case, we have 3 validators here. We have 3 main validators. We have the account validator, like I mentioned, we have the service validator, we have the payment validator, right? Now, the account validator is more or less the first validator, the initial validator being called, because you need to have a user first before you can perform any other action, right? So the account validator has different services in it, right? So as you can see, it calls the account validator kind of like calls the account redeemer function or service or account redeemer function, to redeem accounts. The account validator also calls the account datum function. That's for the spend or for the spend purpose. The account validator also depends on the account param as well. So that is for the account validator. You can see also the account validator has links to the different services, right? It has a link to the payment validator, right? Now, it depends on the payment validator because for a user, we want a user to be able to make payments, right? We want a user to be able to make payments. Now, the payment validator, also connects, or rather depends, it connects to the service validator as well, right? Because the service validator, is the core, right? It is the core that enables us to spend. It's the core that's kind of like enables us to do most of this, different functionalities. Like, for example, it enables us to create an asset in the first place, right? So, and it also allows us to update the metadata as well. So it is super crucial. So as you can see, this is like a high level overview of like how you can design a proper payment service smart contract, right? So you need to like make sure you you know how each one would connect to each other. So moving on, we can go to the specifications, right? Now we've covered the architecture, how it's designed, how each one connects to the other. The next one is the specification. So what specifications do we use? Do they use on for the system actors, for the tokens? You know, from here you can see that the merchant that's on the system actors side, the merchant is like an entity who interacts with the service contract to create a service and receive subscription payments, right? And they have a subscriber as well. This is like the entity who interacts with the account contracts to create an account and deposit subscription fees. So this is for the system actors, right? And then for tokens, you have the service NFT, right? You have the account NFT and you also have the payment NFT. So these different NFTs or these different tokens applies to the different kinds of users, right? So the service NFT is minted by a user when creating a service, right? The account NFT can only be minted by a user when creating an account for the subscription system. Payment NFT happens, of course, when the user subscribes or pays a subscription fee, you know. So yeah, so this is for the tokens. You have like the payment, that's the on the smart contract side of things. Like I said, it's a multi-validator system. So you have the payment contractors, the payments multi-validators, right? This is like the ones that are responsible for managing prepaid subscriptions, you know, and all of that. And then you can see from here the different parameters. You can see how they kind of like detailed, you know, the different, you know, redeemers and all of that. So this is like a very good example of like how a proper documentation should be written, right? So as you can see, they went down to give you, to show you what each of the different service, each of the different functions, you know, function names, what it does, right? You know, so I want to go to the last page. So all of those things, all of these are just like more details on each of the validators and, you know, what service does what function does what, and what each function signifies. Yeah, just one sec. So this is for the account validator as well. You know, you have like the different services, right? The create account, how it's designed, right? You know, like I mentioned, the account validator handles, you know, anything that has to do with the account system, right? So from here you can see, you know, a user, you know, has an asset, which is like the token, the other coin, right? The user proceeds to create an account, right? Now, by virtue of the user creating an account, the user connects to the redeemer, right? The redeemer includes like the account NFT and all of those things, right? And the create account, you know, service in this case, you know, connects you, of course, to the validators, right? And the validator kind of like has like a metadata of the account, right? Things like payments, that's the account contract, things like stake, things like the email hash, phone hash, things like the assets, right? So it kind of like contains the entire metadata, or rather entire metadata of the user, So this is like a high level overview of like how the create account service works. Of course, it has like other parts to it, like the inputs, the mains, and all of that. I wouldn't want to bore you with the details. I just want to, you know, um, I just want to, kind of like just show you how these different services kind of like work together. Okay. So let's see. So moving down to the key takeaways, right? So what are the key takeaways from all these things that I just mentioned, right? The key takeaway is, number one, you have to design first and then code second, right? You have to design first and code second. First off, in what I just showed you, you can see that there was a high-level architecture overview. So which means that the, the creators of the project had sat down to think about the different aspects of the project and then design how they are going to work, how data is going to flow from one end to the other. So it makes sense for you to design first and then code second. So write your architecture diagrams, and design specs before writing any validator code. All right, it's going to help you think through the different edge cases, and it's going to make you code faster. Number two, like I mentioned, is you have to follow a test-driven development. So the purpose, what makes a smart contract is that a smart contract is supposed to be reliable. A smart contract is supposed to, you know, is supposed to work regardless. And what enables it is if you have the necessary tests in your system. So endeavor to write tests as you develop each feature, right? Because it is very important to catch bugs early than to have that bug in production. Number three is property-based testing is essential. So use fuzzy tests to run, 100 plus arbitrary test cases per function. So like I said, smart contracts are supposed to work. They're supposed to be reliable. This is actual funds, people's money we are talking about. So it's supposed to work regardless. You can't afford to miss any edge case, right? Then the fourth one is you have to have separation of concerns. Like I showed you, the way the repo was designed, you have your docs repo, and then you have your lib folder, which contains like the core, right? The core validators. And then you have your validators folder. So having your repo structured like that creates a good separation of concern, even down to the code level. I didn't want to like open the code, because I didn't want this to be too technical. But even down to the code level, you can tell that, okay, this is how a good system should look like, because it has like a good separation of concerns. There are different functions for different services. One function doesn't call all the service, or one function doesn't contain all of the service. Everything has its own purpose. So please make sure that you implement separation of concerns. Keep validators thin and libraries thick. Okay? And then, like I said, documentation is very, very important. Write documentation to help your future self your team, and community. Good docs are as important as good code. Please have it in mind. Now, the common pitfalls to avoid is, of course, jumping straight into coding without planning the architecture. Not advisable at all. Building all features first, then writing tests. Not advisable. The proper way to do a test-driven development is to write tests first and then build a feature to make the test pass. Okay. Number 3, relying on only 1 or 2 manual test examples. No, you have to write vigorous tests that covers every possible edge case. 1 or 2 tests doesn't or shouldn't be the only test that you have to write. Write as much test as possible, cover as much edge cases as possible. Skipping documentation. Number 4 is skipping documentation because the code is self-explanatory. No. As you can see, from the demo, you can tell that it didn't even have to touch the code base at all. I was just going through documentation all through. So all the information that I needed is already in the documentation. It's already documented for me. So this shows that this is an actual, proper, well-designed smart contract project, right? And then the last but not the least, system validation logic. Of course, when writing your validation logic, you should make sure that you cover every possible edge case to enable you to build very robust, smart contract services in your application. For the resources, and in case you want to take your time to go through everything that I just mentioned, there is a link to this session resource. So I'm going to paste the link on the chat. Feel free to go through this session in your own time. The session in this document, you can find the link to this repo attached as well. So take your time, go through it, learn about these things, study it thoroughly, explore the different folders, the validators folder, the lib folder, the test folder, check it out, right? And see for yourself. So yes, I think that's it. Let me share the link to the session resource in the chat as well. This session will also, this recording will also be shared on the YouTube channel, later after this meeting. So once it's uploaded, you can still find the link to the video on this page. So yeah, that's about it. Time for questions. Any question?
Okay, thank you so much for the session.
Okay.
It was very enlightening. I don't have a question for you right now.
All right. Awesome. Any other question? Okay. I guess that's it for now. Okay. Thank you all so much for joining. I hope this was insightful as much as and I hope you also enjoyed it as much as I did. I know this was a bit too technical. It was designed to be. Please feel free to check out the session material that I added on the charts. It's going to come in handy, especially if you want to take your time to go through some of the things that we discussed, right? Yeah. I hope you have a wonderful day, and I'll see you in the next class. Thank you.